Algebra 1B, and we're actually, on Thursday, we're actually back here right now. We did test corrections this day. So SFBA students will be able to use and understand concepts of integer exponents, 6.1. Use and understand concepts of integer exponents. Okay? We're going to do a lot of exponent rules. It doesn't say like, exponents rule, okay?
Yeah.
Although they do, okay? It's just saying like, hey, here are rules for how to do them, okay? So I'm going to ask that headphones are out and phones are away for our lesson, right? Okay? So, I'll just add this.
Headphones out.
Yeah, some people, the nerve of having their headphones in still.
Uh-huh. I can't reach my case.
Okay. So like I said, guys, what we're going to do is we're going to have to split this chapter. So this chapter is 7 sections. But we're actually going to split it. Okay? We're going to split it into the first 3 sections and the last 4 sections. Okay? We're going to split it into the first 3 and last 4. Okay? Actually, we might even just do 3 and 3, cut out the last one. I haven't decided yet. So these first 3 sections, we're going to do like a mini test over. Okay? We're going to do these first 3 sections, and we're going to do like a mini test over. Does that make sense?
No.
Okay. Doesn't make sense, or you're just saying that? Okay. So, exponent properties involving products. Let's write our name though. Mayamo, Senior Castle. So a couple of important notes here. Start off with a variable without an exponent. A variable or number without an exponent can be rewritten that it has a power of 1. AKA, if you just see a normal 3, that's really 3 to the power of 1. Because how many 3's are there? 1. That's what an exponent means, is how many of those we will put together. In this case, it's just one of them.
It's 3.
So if we don't see any exponent, it's really an exponent of 1. Just like, for example, if we have x, and you don't see an exponent, it's x to the first. It's kind of like if we don't see a number out in front, there's really a 1 out there, same kind of thing. It's really an exponent of 1. And the next thing, parentheses are important. The same thing, we just had this on the world, right? Negative 3 squared is equal to negative 3 being squared. This one ends up being negative 1 times 3 squared, aka negative 1 times 9, or negative 9. Where this one ends up being negative 3 times negative 3, because we square whatever's in the parentheses, and negative 3 times negative 3 is normal 9. Okay? So that's just a recap of what I went over on the world. Go ahead and write this down.
How do you know I already did it right now?
Because you were turning talking to Caden as they wrote it.
I don't even know your name, Kate.
Really? Decide you wanted to.
Oh, I would never can.
I know. Mr. Carlson.
That's a good one. Your way's so much like more confusing. My way's just nice and easy.
Of what?
Like the way how you just write it down.
What did you do?
What I did, like I would just write negative 3 times negative 3.
Right. That's what I wrote.
Not on the other one though.
Oh yeah, because it's negative 1 times 3 squared. But this isn't the same thing.
It would still be 9 though.
This one's
No,
negative.
because negative plus negative is positive. Yeah, but it would still be 9.
This?
Yeah.
That's negative 9.
I know. It'd still be 9 though. Like there would still be a 9 for your final answer.
Yes, but it's instead of being positive, it's negative. So the number is 9, but it's negative 9. Okay. So we're gonna have 3 different rules today. Different rules we're gonna learn. The first one is product of powers. Product of powers. Product tells us what operation. Multiplication. Okay. Powers tells us what operation. Exponents. So we're combining exponents and multiplication here. Combining the multiplication and exponents here. So we're saying if we had any A, actually let me back up a second. For our exponents, when we have an exponent here, let's say we have, I don't know, 2 to the 4th. 2, we call the base. We call 2 the base, and we call 4 our exponent or our power. Okay? So 2 is our base, and 4 would be the exponent. Okay? I hope you guys have learned that before, even if you don't remember it. Okay? You guys actually have learned that before, but I'm recapping it, not no-capping it, recapping it. Okay? That 2 is the base. The bottom number that's being taken the exponent is called our base. So for our rule number 1, if we have any base a, it's just saying a is a variable, it could stand for any number. And a is being raised to the power of m. Once again, m can be any number. So it could be like 2 to the 4th, but it's a to the mth. Times a to the mth. Because we have the same base. So I need your AirPod out. Are they both in there? Oh, they are, okay. Okay, so if we have the same base a, and they're being raised to these powers and multiplied together, we can take a, and then we add the exponents. A times a to the mth plus nth. Caden.
So basically, since we don't know like the number for that, it would just be like the plus like it says.
Yeah, but in this case, but when we have these, we'll see numbers.
Can we just use 1?
It's just saying a general rule. Okay,
Like let's
we're
say
gonna-
we're doing like could you put like a story to that whatever and like just use the variables in the story to make that as an answer.
a story or like a problem.
Like you know what I'm saying? Like how we did like the fish or whatever and
You wouldn't typically use this for story problems as much as the ones we'll do.
Like apple.
I don't know egg could you though?
Yeah, it'd be more advanced math, but yes. Okay. Yes.
What if
Two are base
there was
test.
12, like,
We're still
so
down
you're
here.
in the second person?
Yeah, they'd have to be the same. Yeah. That's why they're both A instead of being A. So Grace has a question, what if the first A was like 2 and the second A was 3? Well, they have to be the same. That's why they're both the same variable. That's why it's not A and B. Okay. And exploration. Exploration means we're going to figure something out. Okay? We're going to figure out why this rule exists and how it works. So let's say we have A to the second times A to the 4th. Let's say we have A to the second times A to the 4th. So go and write that down with me. A to the second times A to the 4th. Right next to that exploration. Now, this is going to be the same thing as A squared is how many A's being multiplied together? 2. So it's A times A. That is A squared, isn't it?
Yeah.
A times A is A squared.
Yeah.
A to the 4th is how many A's being multiplied together?
4.
4. So A times A times A times A. That's our A to the 4th. And what's A squared and A to the 4th doing? Multiplying.
Yeah.
So, now if we look at these in one straight line, how many A's do we have multiplied together? 6. So this is really A to the 6.
I think I know how would you so like since they're up there and like how that says m plus m, is that literally all you do?
Yeah. So because these are both the same base A,
So a equals 6.
how do you get over? How would you skip the middle step?
Add the exponent.
Add 2 plus 4. Because we're multiplying them. Because we're multiplying with the same base, you can just add the exponents and keep the base. 8 and 6.
I bet.
Okay.
So like,
Pretty neat.
So like for the bottom ones, you literally do the same thing.
So when we multiply terms with the same bases, we add the exponents. Very good. Okay. Now we're going to simplify this first expression. A to the 5th times A to the 7th. A to the 5th,
I have a different problem.
A to the 7th.
I have
Yeah, I
A from A 3 fish.
Yeah.
You're looking at rule number 2.
Sure about that, Coach?
I feel pretty confident in this.
Oh, it's right there.
Yep, you guys are too far down. You guys are too far down.
Oh my gosh.
So you guys are halfway down the page. We need to be on the top half of the page. Yeah, thanks for saying
I'm
something.
like, what are you talking about?
If you use what you're talking about.
Yeah, thanks for saying something. Yeah, you guys are rule number 2. I know they kind of all they start all the same pretty well. So it's kind of confusing with that. Okay. So A to the 5th, A to the 7th, are we all on the same page now?
So it's 12 at A equals 12.
So it's not A equals 12, but it's a to the
12.
12th. Because you add the exponents, a to the 12th. Because the same base, if they multiply together, we add the exponents.
But the next one's different
But,
because there's
so-
an x to the second in it.
Wouldn't it still be the same though, because that x is the 2 and the y would be for 4?
Okay, well let's calm down 1 second here, okay? So on number 2, okay, well first of all, Sierra, Gracie, you guys good with the first one as well? Okay, just want to make sure, okay. So on number 2, x squared, this y secretly being raised to what power?
2, or 0,
One.
4.
1. If you don't see an exponent, it secretly has a 1 there because there's 1y. This x secretly being raised to what power?
1.
1. And this y is being raised to the fourth power. So, if we were to say this multiplication, x squared y, x, y to the fourth, all of this is being multiplied together, correct?
Sir.
X squared and y is being multiplied, x and y fourth being multiplied, and this parenthesis means they're being multiplied. So what's x squared times x? What would you do with those exponents? Adam, so you have x to the,
Third. Oh, so you go common, like, or whatever.
yep, we keep our x's together, because we have to have the same bases.
So then,
We can't do x and y's, okay? So it's blend y, it's y to the
Fifth.
fifth. Now, can we combine these and go to the eighth?
No, that's the answer.
No, why not? Why can't we do it?
It's not the same.
They're not the same base. This is an x, this is a y. So we can keep the x's together, we can keep the y's together, and they're still multiplying together. We can't say what they are yet.
so can we try this next one by ourselves?
Sure. I think it's a great idea.
Hold on.
See if that one makes sense to you?
This one makes sense.
Alright, go up. Wait, does it make sense?
Yeah, I know,
You messed up.
Wish I did not. I think it's still the same for the picture.
Here, we add
No, I
the
did the first.
since these eggs were multiplying, we added the exponents, right?
They did the 2.
So, is everything here multiplying together? Okay. So we can multiply in any order, can't we? So we don't care if it's like 2 times.
I don't want to do this by myself anymore.
Or it's like 4, or if it's, we don't care what you're doing, because if we do 2 times 3, we get 6, because 4 is 24, Or if we do 3 times 4 first, we get 12. Remember that? And 2 times 12 is still 24. So we can
If
use
you were
x
to
squared
start
times
giving
x.
my heart,
These are the same case.
You should get some Stardust LED strips for this. Ooh, cables. I'm a guy.
Hold up, chill, man.
Hey guys, on number 3 here, guys.
Hold on.
Well, no, let me clarify something.
I don't even know.
Does this come across clearly on your paper? No, it's 1/2, so write that in.
Okay, what?
Does this come across clearly on your paper right here in the third
Oh,
parenthesis?
man.
No, it's 1/2.
Oh, is that?
Shoot?
So you're bringing halves in on this?
I think it's still the same thing. No, it's not. Yeah, it's because look, then you have 3 numbers there. You have the 9, the negative 2x, and the.
Yeah, but since the 1/2 was a positive, you do 1/2 minus 2.
No, I'm saying it's like you have that 1/2, so you'd have a 1. You'd have a 1 on that, and then you, since you're combining like terms here, you'd have a 1/2 in the denominator, and you add those together. Right?
Okay, we're not adding though, but we are gonna put them together.
I'll add the exponents together.
Okay, I think I got it.
So, what we're gonna do here, guys, is the coefficients, the numbers with the variables, we can't add the exponents because our 9 and -2, are those the same base?
Yeah.
They're both numbers, but are they the same base? No, they're different numbers.
Those got an x.
Okay? Well, even if it doesn't have the x, just the 2. Okay? Because we're not concerned that this x has a y, okay, right now. Because we're not doing addition and subtraction. Addition and subtraction, we look for like terms. For this, we're just looking for having the same base. But in this case, since everything's being multiplied together, isn't it? Like even this 9 is being multiplied with this y, the fifth over here. We can't put them together any more than that, but they're even being multiplied together. So what we can do is we can multiply all of our normal numbers together. So 9, negative 2, and 1/2, we can multiply together. So what is 9 times negative 2?
18.
Negative 18. And we're still going to have this times 1/2 over here. So 9 times negative 2 is negative 18. And we're still going to have this 1/2 over here.
So it would be times the half of 18.
Okay? And it will in a moment, yes. But first, let's continue on to our variables. Okay? We like to put the x's before the y's best we can. So for our x's, we're going to have x to the what?
Extra third.
Kate, how'd you get third?
Because I added the 2 and the 1.
2 and this 1 that we don't see there. Okay? So we're going to have x to the third. What are we going to have y raised to? No blurting. What are we going to have y raised to? No blurting. Okay? Gracie. 10. Y to the 10th. Gracie, how'd you arrive at 10? Add the y exponents. 2 plus 3 is 5. Plus 5 is 10. Okay? Now, can we still multiply this negative 18 to 1/2? Yeah. Now, a way you can think about this is you can do that like normal fractions. Negative 18 over 1 times 1 over 2. Can we cross reduce?
Yeah.
Heck yeah, we can. What goes into both negative 18 and 2? 2. How many times does 2 go to negative 18? How many times does 18 or 2 go to 18, guys? 9 times. And 2 goes into 2 how many times? So we end up having negative 9 over 2, or just negative 9. And also, is negative 9 half of negative 18?
Yeah.
So we took 1/2 of it. So negative 9, x cubed, or x to the third, it's also called cubed to the third, and y to the 10th.
You can't be targeted.
That would be the answer.
That would be our answer. Because we can't do anything more than this. So we multiply all the normal numbers together. We still multiply our normal numbers together. And now when we multiply our variables together, we add exponents. So we're still multiplying like normal with our numbers, but when we multiply the variables, we have a twist of we have to add the exponents, okay? We have the twist, but we have to add the exponents.
So you got the negative 18, was it from the 9 and the 2?
Yep, that's 9, that's negative 2. Very good, yep. And I didn't want to multiply 3 things at the same time, so I just held off on the 1/2. So the reason I didn't multiply the 1/2 at the same time is I didn't want to multiply 3 things at the same time. So I get a little confusing.
I have to put arrows in these places because this is really confusing.
What are you doing for Valentine's Day?
So Hannah doesn't want to do anything for Valentine's Day, but this is also our first Valentine's Day together, so I'm playing it safe and doing something for Valentine's Day.
Playing it
Because-
safe.
Well, the last thing you want is
It's
like
not
for someone to
safe.
say like, you know, oh, they don't do it so you don't do anything, and then like they realize later like, oh, I actually would have liked something. You know, like it's not gonna do anything big. So like she really likes to like going rock climbing. Okay, so she like there's a rock climbing gym at UNO she loves going to. And so what I'm gonna do is I'm gonna write her a letter, and because we write each other letters sometimes, so I'm gonna write her a letter, and then I'm going to just put a couple envelopes together, and it's just gonna be the entry fee to the rock climbing gym. So I'm gonna give her like a couple of them and say, hey, like, you know, take yourself rock climbing a couple times, kind of thing. And so we're just gonna kind of hang out, have our normal Friday night date night, and just time together, and I'm just gonna kind of give her that. So
Are you going rock climbing?
I've gone with her before. She kicked my butt. She's really good. So.
So she's really good, you're really bad.
I mean, this is my first time going. I was decent. I'll give myself decent.
Dude, I have to work all day on Valentine's Day.
Really?
That's rough.
Dang.
I'll visit you.
Dude, Michaela's gonna be sad.
So how does everybody know,
What?
dude?
Dude, you gave her your hoodie in front of my door the other day.
I still don't have that hoodie.
Oh, duh.
Yeah, and that's a $90 hoodie.
That's how that works.
Give her a $90 hoodie.
Not
That's
Is that your voice?
Ice.
Yeah. You don't get them back.
But you need thousands of money.
Yeah, sometimes you get lucky and you can make a trade. That's the best you can do. That's the best you can hope for.
I'm trying to
As a
get
trade.
trade.
It's
I
all
like
really
that.
oversized
I
teddy.
can work this shit.
Yeah, the best you can hope for is a trade.
I'll probably ask for a trade.
Just saying. That's my wisdom to you guys. You will never get those back. Best you can hope for is a trade.
That's why you don't have a girlfriend.
Of course.
That's why he's got a
Yeah, like
fiance.
that. Got a
Boy.
fiance. So I mean, pretty soon we're gonna share a
I'll
closet.
be-
So
I'll
even
be
if
with
she
my
hasn't,
boys.
So like, I'll actually kind of get them back.
Yeah, I know. I gotta trade something.
I'll
So
be
life
with
hack.
my
The only way you truly get it back is
To marry
you marry her,
Or
or you
Or just
break
break up
up,
with her.
and then you hope they don't throw it away or burn it.
It's
So
possible.
scary.
Right?
I'll just break up with Mikhail.
I'm gonna be with my boys.
You what?
My boys on Friday.
You hang out with your boys?
Yep.
A for Valentine's Day?
Yep, and if Tony gets off on time, he knows him too.
Oh yeah.
I'll go somewhere.
His district, so.
Not 11 o'clock. I'll be there.
They close
Yeah.
at 9, so yeah.
Is this your wrestling?
I'll get off from there.
They're gonna go to that?
It's 2 hours away.
Ooh, where's it at?
I'm trying to find this one.
Where's he going?
He goes to
Show Rachel.
Oh yeah, yeah.
Oh yeah, you know Rachel Dyer, right?
And
You
Carmelo.
see her TikTok? She went TikTok famous after this movie.
41K likes and like 163K views.
Who's it with? Did she make one with Carmelo? Is it good or is it trash?
It's good.
It's her last movie.
Took on a plane.
Oh, yeah.
That's actually a pretty good way to ask.
That's impressive. You want to or not? You want to or not? Don't do what? Look at Trace Ellis.
That's a little too much money for me.
Yeah,
I'm gonna quote that so much.
What if
tomorrow.
she,
I have
what
her
if she said
class
no though?
tomorrow.
What if she said no?
It'd be big awkward. I mean, they've been dating, so like it'd be awkward. I mean, at that point you just kind of expect they're gonna say yes.
I would have thrown out the plane without
He's
a
out
parachute.
that plane.
Hopefully she lands
That's
on a
where
big
it
patch of
goes
snow.
fun.
I got
Okay, we're gonna continue on to rule 2. Power of power. Okay, so this means an exponent of an exponent.
That's easy.
We're gonna take an exponent to another exponent.
That's easy.
If we have a, any base a, it could be 2, it could be 4, it could be 3, it could be 2,412. To the nth power, no, it's bad. To the nth power, and this is all being raised to the nth power. What we end up doing is we have a to the m times nth power. We end up multiplying them.
Manpower.
So, okay, our exploration for this, let's write this with me, please. We're on rule number 2, by the way. A to the second, in parentheses, being raised to the 4th. Write that like that, please.
Wait, why is
Thank
it
you.
raised to the 4?
Trust me.
Oh, you just put numbers.
I just put random numbers.
Oh, okay.
That's our random numbers. Right now, 2s are m, 4s are n. Okay? So a to the second, all being raised to the 4th. So what this would literally mean, guys, is this being raised to the 4th, is it means there are 4 of whatever is inside the parentheses being multiplied together. There's 4 of whatever's inside the parentheses being multiplied together. So what's inside the parentheses? A squared. So what are there 4 of being multiplied together? A squared. So we have a squared times a squared times a squared times a squared.
Answer.
That's what a to the 4th means. 1 second. That's what a to the 4th means. Tony, I need you to follow along with this, please. Okay? But I need you to follow along with writing it down too. Okay? So a squared, all being raised to the 4th means there's 4 of whatever's inside the parentheses. In this case, a squared is inside the parentheses, so there's 4 of those being multiplied together. So now, do we have the same base with all of these? A squared, a squared, a squared, a squared? So what can we do with those exponents?
Add them up.
Add them up. So we get a to the, Caden?
8.
8th, a to the 8th. Now, if we were to have life hacked and gone straight from here to here, how could we have done that? How would we get 8 from 2 and 4?
Wait, what?
If we were to life hack and go from here to here and skip over this middle part so we don't have to do it every single time, we multiply the 2 and the 4. So when we have a power, an exponent being raised to another exponent, an exponent being raised to another exponent, we multiply the exponents and keep the base.
It's like the bottom one is like 15, 12, and 6.
So when we raise a power to a power, we blank the exponent,
We
we multiply the exponents.
I should take good notes.
Hey, good. I see it. I'm proud of you guys. Okay? You gotta walk it in my pocket. Walk it
These
in
are
my
Brady's
pocket.
not here.
Walk it in my pocket. Okay. A to the third being raised to the fifth. So power being raised to the power. So what do we do with these?
A equals
Multiply. So we have a to the 15th. Okay? Sierra, I want you to try this one. X to the fourth being raised to the third.
If I don't find something so clever.
Yeah, x to the 12th. Very good. We multiply those. Okay? Gracie? 2 to the second being raised to the third. 2 to the 6th. Now, with this one though, can we go farther? What can we do? Okay, now Gracie, I'll be honest, your enthusiasm's scaring me. Okay? Your enthusiasm's scaring me a bit. Okay, you need to tone it down. Okay, that was too much. Okay? So, we have 2 to the 6th, which we can actually continue out doing, okay? Tony, I know you had the 2 to 6 written before, we're going further now. Okay, I'm letting you know. I know you already had it.
Wait, how do we
We're gonna do
separate
it.
that? Separate that if we're doing
What are you asking? We can't do it on a variable because do we know what the value of x is?
no.
But do we know what the value of 2 is?
No, I just put so like I put equals to 6, like 2 to the 6. I was wondering how I can separate that.
What do you mean, like how you turn it into this?
No, like how I could like separate it, like I could like a dash.
Like how do you go from here to here?
Yeah.
Like how do you say it's the next thing?
Yeah.
You can put equals 2 times 2 times if you're doing it on a line.
All right.
Is that what you're asking?
Yeah.
Okay. Good question. Now I really want you to ask those questions because that's an organizational question, and organization helps us do our math better. Okay. So here, what's 2 times 2?
4.
4,
What's 2 times 2?
8, 4,
What's 2 times
Four.
2?
4,
No. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is
4.
4. Now we have 4 times 4 times 4.
16.
12.
4 times 4 is 16.
16.
And now we have 16 times 4. We carry this one now, we haven't used it yet. 16 times 4 is
64.
64. So 2 to the 6 is 64.
I just.
Does
did the
what
two-
does what I did here make sense?
Yeah.
Okay,
I just went down the line.
Yep.
2 times 2 is
you have 4, 8,
6,
16, 32, 64. You want to do that way? You can. Okay, questions on that?
There's not a lot of room to stretch in these chairs.
No, chairs aren't normally meant for stretching.
Honestly, I wish we could get those like desks, like where you pull a chair up to, and then it's like small like this, and then once you get
Like
started
you
sitting,
pull.
you just move your chair back, and you can pull it up, and you can stand.
Oh, like a standing desk?
Yeah.
Yeah, what?
A standing
I
desk?
wish we could get some of those.
Like you can just you can lift up the desk. Mr. House has one in his office. Next time you're in there, ask him about it.
That's what that is.
Wait, what? Like
So,
just,
like,
just the top of the stuff?
Well, yeah, so it just it has a
You did that. You gotta use your wrist
I
really
So,
wasn't trying to flip it.
you can expand it up
Oh.
and then push it back down and compress it.
Like it
So
can
you can
actually.
sit or you can expand it up
I'm
and
not trying
sit.
to throw it.
It's it can be better on your back for if you're just sitting all day. Because sometimes so a lot of people in offices will have them. Will invest in a standing desk, so that way they don't have to just sit all day every day.
We need to invest over here.
Maybe. The good thing is that we do have the walkie brakes, but they're so expensive for every student has, so that's the downside.
Should like 2 in each class.
Yeah, but then it's who decides who has them?
Good kids get them.
Once
So you guys have never had them?
if you can see that someone's sitting there, they can't sit still and not
Actually,
focus,
today I would.
let them stand.
You gotta do it this way.
I don't care.
Continuing
I'm
on,
just giving you pointers.
we have our last rule for today.
I don't know.
Power of a product. So we have product of a power, a product of powers multiplication of exponents, multiplication of exponents, I said that weird. Now we have power of a product. So we're taking a multiplication and raising it to a power. So we have a times b, so it could be any number a and any number b, we multiply
A
together,
times B equals C.
and we're raising it to the nth power, raising all of the nth power. So what we do is we have a to the nth and b to the nth. We have a to the nth power and b to the nth power. Let's do an exploration on this one, guys. So I want us to do a b squared in parentheses, and this exponent of 3 on the outside. Okay, so ab squared in parentheses, all being raised to the third power.
So I mean, it'd be A, B, B.
Okay, so this power of 3 just means it literally means that we have 3 of whatever is inside the parentheses being multiplied together. So what do we have 3 of? A.
1.
Okay, so this power of 3 means we have 3 of whatever's inside the parentheses.
Also A3.
So AB
Oh.
squared times
Oh.
AB squared times AB squared. That's what this means. There's 3 of whatever's here
So
being multiplied together.
it'd be A, B to the 8.
Okay, not quite.
Yeah.
Okay, brilliant.
Dude, there's no need to try.
What do we do with our A's? A to the. If we had this on our first roll, what would we have done with these? Third power. 1 plus 1 plus 1.
But then,
B to the
1, 2, 3, 6.
6. So we have A to the third, B to the 6.
Mr. Costello, you gotta try one of these.
Gracie, you gotta let me try one of those too.
Make your pop guard. They're like better than the actual pop
Let me try one.
Susie, can you toss me one?
Can I try one?
No.
Gracie, may I please try?
Yeah, please try one.
There we go.
I wish I could have popcorn.
Gracie,
but I
Maurice,
don't know
down.
how to eat.
Say a little name.
Whoa.
What is it? I'm sorry.
I thought you were right.
Apparently,
What is it?
Elizabeth.
Oh, Gracie Elizabeth Stoner, may I please try one?
May I please have one?
Yeah, what name was it? What's your good?
Alright, Sherry, want one? What? Shut.
Genius.
See,
Ah,
You were just said you were not allowed.
I know, but I
Thank
don't
you.
do it behind my mom's back.
What if I send her this video now and she can hear it?
Oh, these are fire.
Okay. Fire starter.
They're good.
Yellow.
They're soft.
Those are really. Dude, my roommate, he like loves impulse buying like sugary cereals. And so he impulse bought this Pop-Tart cereal. It was disgusting.
Really?
It was so bad. Okay.
I like, hold on.
So how would we have jumped?
Before you start back at me, please. Have you guys ever tried the blueberry cinnamon toast crunch? Those are fire.
Yeah.
Sounds gross. Oh, those are fire.
Have you guys ever had waffle crisp?
Yes.
It's really good.
Honeycombs?
Honeycomb's good too.
Fire.
I don't eat
Okay.
them.
Wait, you guys know Cookie Crisp?
Yes.
Yes.
Okay. My fiance had never had it before. Okay, and I had some at my house. Okay, because like so I bought a house over last summer. Okay, and my at the time girlfriend but now fiance, her parents got me a housewarming present, super nice one. And so they were like, oh, what kind of food do you like? What kind of food would you like? Would you want us to get you if you want us to get some? So like, and I asked for food I would never buy myself, but I love eating. And so I asked for pizza rolls, Cookie Crisp, like Captain Crunch. And so I'm like, I would never buy them, but I love eating. So it's like someone else is buying food for me. I'm like, heck yeah, I'll pick that. And they had no idea what Cookie Crisp was. They never had it before because they're like healthy and whatnot. And I'm like, okay. And so Hannah had never had Cookie Crisp, and so like I actually just finally opened the Cookie Crisp because cereal lasts for a while if it's sealed still, if it's not open. And so like I just opened the Cookie Crisp for the first time like a couple weeks ago. And so like Hannah was over like last week, and like she wanted to try some of the Cookie Crisp. I'm like, sure, and she was eating it, and she's like, this just tastes like regular cereal. And I'm like, put it away. You don't deserve to eat the Cookie Crisp. This stuff is fire. If you can't appreciate it, you don't deserve to be eating it right now.
Wait, what does regular cereal taste like?
I can't remember what she was saying, but she like just compared to like it doesn't even taste like cookies. I'm like, that's wrong.
It does.
It actually does.
It does.
It does.
It does.
Especially if you put milk on it. She didn't have milk on it, but still, it still tastes like cookies.
When
I was doggered.
When they get soft.
Pro
they
tip.
get soft.
Pro tip: if you have like cookies, like actual cookies, okay, and like they get old, so they get like they get hard. You know, you know what I mean? Like,
Yeah.
after a while, if you don't eat them right away, they get hard. Okay? Crunch them up a little bit, put them in a bowl of milk. It's so good because they get the moisture back in from the milk, and it's like cereal.
Have you ever,
If you don't eat it quick enough,
Have you ever,
it's like cereal with salt.
ever put milk, like, so you put ice cream, right?
Yeah.
Then you put like strawberry milk, chocolate, whatever milk you want, and you mix it, and it turns into like a smoothie.
That's
Like
literally a
you eat it, like,
milkshake, homie.
You know, it's got some milk.
yeah, they're
Homemade
so good, but it's not a milkshake, 'cause it's like,
pretty much.
No, it's
It's
a
like-
milkshake in a bowl.
yeah, but it's like, I know, but it's like way more like thick.
I know what you mean, like you can do it with regular ice cream too, you just sit there and mix it.
Yeah.
and yeah.
It's like, it's a lot more thick, yeah. It's a lot
Literally
thicker
like
than a
a
milkshake.
Woo, okay.
Yeah.
Going back to this, dial it back in, dial it back in.
You have to try it.
Let's dial it back in so we get some good work time here, okay?
It tastes different.
I think we can get probably at least 20, 25 minutes of work time if we do this right.
Yes, sir, let's go.
Okay? AB squared being raised to the third. We said this was AB squared, which said it was a to the third, adding the exponents, b to the sixth, adding those exponents. So if we would have gone straight from here to here, we could have taken this 3 and done 3 times 1, a to the third. 3 times 2, b to the sixth. So if you were to go straight from here to here,
Ooh.
you would do this 3 and you multiply it to the exponents.
Why don't we just have to do it the easy way?
We are going to do it the easy way. We're going to do that right now. But the first time we learn it, I want us to see why it works. Okay? Here's the thing. Here's the cool thing about math. Okay? Here's the thing about math. Okay? There's a good chance, depending on your careers, you might never actually use this specific math rule in your career. You might not. You might not. We don't know. But the thing about math is you will use the problem solving and critical thinking that comes along with it.
Yes,
You
sir.
will use problem solving and critical thinking regardless of what you do in life.
I'm trying to be a game.
Okay? So
So do you mind introducing
the
me on
reasons
how
why
you
we
money?
do things are important. That's why I'm so big. Hey, that's why I'm so big on the reasons why we do things, is because that's the takeaway from math that most of you are gonna have. Okay, or at least from some of the math. Okay. When we raise a product, hey,
Focus
focus
on math.
Hey guys, focus in. We just took a little brain break for Pop-Tarts and cereal. Okay, focus back in. When we raise a product to a power, we have product multiplication being raised to a power. We blank the exponent. What math is this? Multiplication, we call it what?
Subtraction. Divide. Division.
This way, so
Distance.
this way, so what do
Distract.
Misdirection.
Distriction.
we
Distribute.
Distribute.
Yeah!
That was brutal. Okay? You take the exponent to each exponent. You take the exponent on the outside of the parentheses and multiply it to each exponent inside. Holding on.
What was the word for the other one? For rule 2, do we not have a word?
Multiply.
Hold on.
I am.
Alright, we're good. Hold down. Alright, you can.
That's push down.
That's holding down, though. This is holding something down.
Well, you.
Yeah, that's how you.
Pull something up. Keep it up, Tony.
That's me, Chris. That's easy.
It's like, hold down.
Yeah. Anyway. X squared y being raised to the fourth. How would we do this?
Add it.
Distribute, boy.
So it's x to the
Oh.
y to the
Oh. My four.
fourth. X to the eighth, y to the fourth. Can't do anything more.
So basically distributing backwards.
Boom!
Okay, so if there's one parenthesis
Oh, got
outside, if there's one exponent outside the parentheses, when there's another in the distribution.
Yep.
Hold on.
It's like rule number 2 repeated. It's like rule number 2 repeated.
No.
Rule number 2. Yes. Rule
No,
number
no.
2.
It's like no.
Let me finish.
Let me finish. You're being so disrespectful.
Rule number 2 was with this parenthesis outside. We multiplied the exponent. 3 times 5, 15. 4 times 3, 12. 2 times 3, 6. Here, 4 times 2, 8. 4 times 1, 4. We just repeat rule number 2. It's rule number 2 on repeat. Okay? What are we gonna say?
Just say it's just like distributing, but like it's backwards.
But only
So
to
like
the
you don't
what?
start from the left to the right, you start from the right to the left.
Okay. And we're only doing it to the what? We're not doing it
That's
to
fine.
actual
We're
numbers.
only doing it to the
exponents.
numbers. The numbers.
We're only doing it to the exponents.
You know,
So like on here, 2p to the third, q to the second, all being raised to the third. What do we do this with this
Go
exponent of 3?
3 times 2. No,
3 times 3,
3
bud.
times 3.
Okay, that's also true. So p
Which
to
is
the
9. P 9. And then you go 3 times 2, which is 6.
And then you add a 1 to that 2, and then you go, it's 3.
so it ends up being 2 to the
2
third.
and then that's
Okay.
answer.
Common mistake I see here, guys, is we'll multiply the normal 2 times our exponent of 3. We can't do that. We never multiply a normal number, a base, with the exponent. We never do that. Now, what is 2 to the third? We said in our warm-up it was something.
16.
Nope, 2 times 2 times 2 is 8.
Well,
So this is
like
8, p to the 9th, q to the 6th. We don't know what p and q are, so we can't finish that off any more than that. Questions on that? Okay. So on number 3, we get a little bit more going on here, don't we? Okay. Well, Pete,
Wait.
Wait,
Where'd you get that 8 from?
oh, he times
that's 2 to the third.
2 times 2.
It's 6. I see.
Wait, 2 times 2 times 2. 2 times 2 equals 4. 4 times 4 equals 8. Okay. 4 times 2 equals 8. Yeah.
So at number 3, we want to do PEMDAS still. We want to do PEMDAS, please consider doing it for simplifying expressions. Parentheses. Can we do anything inside this parentheses with this 3g to the third, h to the fourth?
No.
Can we do anything inside this parentheses, 2g to the fifth? No. Now we move on to exponents. Can we do anything with just this exponent g to the third?
Yeah.
No, we don't know what g is.
Or
Can we do anything with this exponent h to the fourth?
No.
Can we do anything with this exponent of 2?
Yes.
Yes, what can we do with that?
Oh, because it's different distribute. There's 2 distributions.
Okay. And so this is really 3 to the first. So it becomes 3 to the,
Don't count mine.
thank you, Sierra. This becomes g to the, this becomes g to the 6th, thank you, Sierra. This becomes h to the 8th, very good.
Okay.
Now in my next parenthesis for exponents, okay, can I do anything with just this h to the 5th? Can I do anything with this exponent of 4? Yes. I can distribute as well. So this becomes 2 to the 2 to the 4th. Because it was really being raised to the first before. This becomes g to the
4th.
Yep, being raised to the first before. And this becomes h to the
20th.
20th. Very good. Now, okay, can we do anything with this exponent of 3 squared? Do you know what 3 squared is? Yeah, so we can. So this becomes 9, g to the 6th, h to the 8th.
Wait, how do you get g to the 6?
3 times 2 for the exponents.
I'm on the other one still.
Okay.
2, 4, 2, 4, h.
Now 2 to the 4th,
Which would be
4.
16.
16. We need to write that off the side. 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. G to the 4th, h to the 20th. Now, is this kind of like what we had earlier?
Yeah.
Yeah.
Yeah. So now we have to multiply 9 times 16. Now, we probably don't know off the top of our head, right? That's okay. 16 times 9. What's 9 times 6?
9 times 6 is 54.
Yep. 9 times 1
9.
plus 5.
50.
14. 144. What do we do with our g's? G to the 6th and g to the 4th? Add them. G to the,
10.
and this becomes h to the 28th. And that's our answer. 144, g to the 10th, h to the 28th. I feel like this stuff kind of gets a little fun after you kind of start understanding it personally.
Nah.
Not really. Okay. Can you wait like 5 minutes or no?
Wait, how do you get the 144?
I guess. Mr. Costello, because I always thought of
Wait, did you just add the 3, 9, 12, and 16 all together? I mean the 9 and the 16.
9 and 16 multiply, 'cause everything's here multiplying.
Oh, so everything.
So 9 times 16 is multiplying. G g to the 6th and g to the 4th are multiplying, but because they're the same base, we add the exponents. h to the 8th and h to the 20th are multiplying, but because they're the same base, we add those exponents. Okay?
We have 144 8 to the 10 and then 8 to the 20.
Okay, 8 28th. 8 plus 20 is 28.
Okay, got it.
We're actually going to skip over number 4.
How come our 1/2s never come out right?
I don't know. I don't like it. It is a recurring theme, though, isn't
Can we try to do this one by ourselves?
it? Sure.
Since
You can try to do number
we've already
5.
learned this one. What,
Try
you can say, but I can't?
And let's try to do number 5 on our own. I think it's a good idea.
I thought it was Anthony. Good boy. The rest of the right one? Is the rest of the right one?
Because they're not the same base. We did 2 squared.
Yeah.
Maybe we multiply 4 negative.
And then,
What power is this being raised to? Reverse. No, you raised to left.
Oh, it'd be 3 because you're out, right?
Multiply 2 times 1 is 2. Plus 2 to the 2nd, x to the 2nd. Just like here.
What?
Just
Yeah,
like
you got it.
Here you have the 4. You have the 4 times.
Oh, sure.
So it's 2 to the 4th. Oh, we just do it work.
Right there.
That's it. Yep. Then we keep going from there because we know 2 squared.
Then add them, right?
No, so the exponent is actually just on this x. Because it's really just negative 3 to the first. And then we agree all this. So this is still just negative 3, and this is still just negative 3. So then we multiply that, and it would be a little different.
Do I add the rest of those ones?
Mr. Castle.
Like all the 2s?
Because they're not,
Okay, I got it now.
with this is, they're like, not like terms, what is 2 squared? So we actually do that math. Yeah. Yeah, so let's break them.
Okay.
Second break.
Mr. Castle, did you see what was uploaded on the Castle pool page?
So was that, yeah, so what, it'd be 2?
Yeah, that's right. Or yeah, let's do that. That'd be like what we did on 4 3 seconds.
I probably best for yours.
No, it's just 4,
Hmm?
it's space.
Yeah.
That's so funny. Did this just happen? Oh, I was ago.
No, you do.
So late.
Negative 3 days.
How long is it?
Times 4.
Well, we're like,
Yeah, sounds about right.
that's cute.
No, just negative 3 times.
That's nice. So 12.
Negative 3.
Older and married too.
And then you
For
would
once and for all, it is.
space x2.
Can't wait to be an adult.
And then the y is, would be 2, so it would be 5.
Oh, I got it.
Space would be
Wow.
Wow.
Yep. Look at it.
I got the answer.
2y all being squared. So, can we do anything inside this parenthesis with this 2y? No, we can't multiply 2 and y. Can we do anything with this exponent on x squared?
No.
But can we do this exponent?
Yes.
Yes. We can distribute it to these exponents, which are both being raised to the first. So we have negative 3x squared, which stays the same. Then we have 2 squared, y squared. Now we can actually do 2 squared now. Just like on the number 3, we can actually do 2 squared. So negative 3x squared times 4y squared. And then we say, okay, well we can't multiply x squared and y squared anymore because they don't have the same base. One's x, one's y. But we can multiply negative 3 and 4 because those are real numbers. So negative 12, x squared, y squared, and that is our answer.
Wow.
Question on this?
Hey, it's been 5 minutes.
Okay, it has been 5 minutes. Okay. Let me briefly explain this one. Okay. I thought it was going to be 5 minutes, but we ended up taking a little longer. That's my bad.
I know how to do
Okay.
this one. I'm pretty sure.
So on this one, you have to be really careful with this negative. Okay, remember we have to be really careful with this negative. We're going to think of this as a negative 1. We're going to think of it as a negative 1 there. Okay? And what power is this negative 1 being raised to?
It's being raised to the. Wait, what?
The first. What power is y being raised to?
1.
First. Now what can we do with this exponent of 4? So this becomes negative 1 to the fourth, x to the third. Try again.
12.
12. Y to the
Fourth.
Now, once we have this, I'll give you a second to write that down. Give you a second to write that down. So follow along with me. Negative 1 to the fourth, we can actually do that. Negative 1, how many times?
Wait, why did you write the negative one in there?
I'll explain why.
Positive 4.
What's negative 1 times negative 1?
1.
What's negative 1 times negative 1?
Negative 1.
What's 1 times 1?
2.
What's 1 times 1?
Oh my God.
2. What?
So we have 1
Sorry.
times x to the
That's
12,
my part.
y to the fourth. Yeah, I thought it was so bad.
Yeah.
What's 1 times anything?
One.
It's
Itself.
itself. So we just have x to the 12, y to the fourth as our answer.
God damn, man.
Now,
Are you assuming my gender now?
hey, what would have happened? What would have happened if this was being raised to the third power? What would happen if we had negative 1 to the third power?
It'd be 3. Negative 3.
When we had negative 1 to the fourth power, we had positive 1. If we had negative 1 to the third power, 3 negative 1s being multiplied together, then what's negative 1 times negative 1? What's 1 times negative 1? We would have gotten negative 1, wouldn't we? Would that have changed our answer? Okay, so the reason why we're very careful with that negative is to make sure that as we distribute this in,
When did you grab the carrots?
when you guys are doing number 5, sneaky.
I was like, what?
So that's why we put this negative 1 here, because we have to be careful with our signs. Okay, we put the negative 1 there and distribute that as well. We have to be really careful because if we had an odd exponent, this would have been a negative answer. Okay, question on that. Okay,
Oh. 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 Easy there, pal. Oh, alright, you go stand over there.
okay, you guys want some don't do's?
We're gonna do.
Yeah, you
Don't
could.
do all of them.
Well,
Stand there.
I don't want you crossing any of them out though, okay?
I give you one shot to hit me. I give
What?
one shot to hit you.
No.
So if you don't have to do them, I don't want you crossing them out today though.
Is this like a 2-day?
Ooh. Mine went the same.
Watch out.
Go on 3, 1.
So I want you to not do, or here's the ones I want you to do, excuse me. Here's the ones I want you to do for next class. I want you to do the odds.
The odds.
Yep.
It's like 1, 3, 5, 7, 9, 11, 13.
Yep, the whole left side.
3.
Actually, let's just do the odds for next time.
Here's your card. Mr. Castro.
Let's just do the odds.
P3.
So let's just do the odds like for next class.
That's
so
on.
I want you guys to do the left side of the worksheet for next class. Do not cross out the right side. We'll do the right side later. But I want you guys to do the left side for now. Okay?
Where's mine?
So I want you guys to do the left side only. Do not cross out the right side. Questions on that?
No, sir.
Yeah. Give me a second.
Please don't steal it.
That was a good one.
Please don't steal it.
Oh,